Hello everyone. In this video, we are going to discuss about the introduction portion of this chapter Current Electricity, chapter 3 of class 12 physics, as well as electric currents in conductors. You see, we know that the flow of charge or charges in a definite direction that constitutes the electric current. More generally, we can define the current as if delta Q amount of charge flowing across a cross section of the conductor during the time interval delta T, then we can write the current as I is equal to delta Q divided by delta T. Then the current at any time or current at a time, that is current at an instant or current at a time t across the cross section of the conductor can be written as I of t is equal to limit delta t tends to 0. That is, we have to reduce this time interval to 0 and delta q by delta t. So this will give you the current at a time t. You see, this current, it is a scalar quantity. Current is not a vector quantity. See, we know that current has magnitude like 1 ampere, 2 ampere, etc. It has a direction. It is conventionally, it is directed from the positive to the negative. But current is a scalar quantity. Why? Because current follows the laws of scalar addition but not the laws of vector addition. That is, angle between the wires carrying currents that does not affect the total current in the circuit. So current is not a vector quantity, it is a scalar quantity. Now let us talk about the electric currents in conductors. You see, we know that all materials are made up of atoms and molecules where the negatively charged electrons and positively charged nuclei are bound to each other. In some materials, electrons, they won't get accelerated even if an electric field is applied. Such materials are actually known as insulators. For example, wood is an insulator. But in some materials like metals, some of the electrons are practically can move within the material. They have, such materials are actually known as conductors. See, these electrons can develop an electric current in them when an electric field is applied across the conductor. Now, let us consider a conductor. Here it is cylindrical in shape. That is, consider a metal object when no electric field is present. See, electrons in the object will be moving randomly. One electron will be moving in this direction. After it will be colliding with the fixed positive ions. So after the collision, they will be moving in another direction. So electrons are actually moving in random directions. So electrons in the object will be moving randomly and colliding with the fixed positive ions. An electron colliding with an ion gets deflected with the same speed, but direction of its velocity after the collision is completely random. And on an average, the number of electrons traveling in any direction will be equal to the number of electrons traveling in the opposite direction. So there will be no net electric current in a conductor or in a metal when there is no external electric field is applied across it. Now let us see what happens if an electric field is applied across the conductor. See, here I am taking two circular discs made up of dielectrics and have the same radius as that of the cylinder. See, Q number of positive charges are distributed over one disk and Q number of negative charges are distributed over the other disk. See, these two disks are attached to the flat surfaces of the cylinder. So, an electric field will be created which is directed from the positively charged disk towards the negatively charged disk. And electrons get accelerated and move towards the positively charged disk. Now, see, there is an external electric field present here and these four positive charges are marked here and negative charges are marked here. See, electrons are moving against the electric field and this electron will be moving towards the positive plate, and on reaching the positive charge, they neutralize the charges on the disk. And the second charge also moves to this direction, it neutralizes its effect. Similarly, the unidirectional flow of these electrons constitute an electric current which exerts only for a short time. That is, the electric current exists in the metal or the conductor as long as the electrons are in motion or till all the charges are neutralized. And if we want to, that is, there will be an electric current flowing through this conductor when there is an external electric field present here. And if you want to get a continuous electric current rather than a current for a short period of time, we can provide a steady electric field by connecting it to a battery, to the conductor. So in this video, we just discussed about the introduction part of this chapter, current electricity, as well as the electric currents in conductors. I hope it is clear to you. Thank you.